says grain pouring from a chute at a rate of 8 feet cubic feet per minute forms a conical pile whose height is always twice its radius. How fast is the height of the pile increasing at the instant when the pile is 6 feet high? Right? So you can imagine we have a picture like this. Right? We have some grain poured into, it's kind of forming this conical pile here. Right? So what are we given? Grain pouring from a chute, grain pouring from a chute at a rate of 8 cubic feet per minute. So given that dv dt, because now we're talking about the volume, cubic feet, the volume. So the volume is increasing at a rate of 8 cubic feet per minute, right? Now that also gives us something that is very important here, right? A conical pile whose height is always twice its radius. So the height is going to be 2r, right? Twice its radius. And this is important because in the formula for a volume, the volume of a cone, it has two variables, right? Right? It has two variables. And so if you look at what we're really trying to find, we're trying to find dh with respect to time, right? Because how fast is the height of the pile increasing at the instant when the pile is 6 feet high, right? So again, we're gonna find dh dt when h is 6 feet, right? So the volume of a cone is equal to 1/3 pi r squared, pi r squared h. And so that's the volume of a cone, right? We have two variables here, right? We know nothing about the radius, so here's what we're gonna do. I could solve for the radius here. So divided by 2 on both sides, my radius is just gonna be 1/2 the height. All right. So now I could plug this into the cone, to the formula, and say, okay, well, 1/3 pi h over 2 squared h, right? And look what this does. Again, you should imagine that there's a 1/2 in this. 1/2 squared is just 1/4. 1/4 times 1/3 is just 1/12, right? So the V cone, so the actual cone is just going to be 1/12 pi h cubed, right? Because we're squaring this h and we have an h here, so we're actually getting a cube h. So this is a formula that we need. And here you can see that it totally takes care of this ambiguous stuff, this r that we didn't really know anything about. So now we're just okay to take our derivative. All right. So starting from here, dv dt, take the derivative of v, and that is going to equal, well, again, 1/12 pi, I'm going to put my 3 here because I'm taking down my 3, h squared, right? All I did was just bring down my 3, took my derivative. Now this 3 and this 12 will cancel to give me 4, right? So now we have dv dt, and that's just going to equal 1/4 pi, well, or h is 6 feet, so 6 feet squared, right? Well, what will that give us? Well, again, and maybe I should go across here. So dv dt will not just be equal to 1/4 pi 36 feet squared, right? 36 feet squared, dh dt. And I forgot my dh dt as I was going along, so I'm sorry about that, guys. Here should be a dh dt, right? As soon as I took the derivative here, I should have had my dH dt. Right, so I missed my dH dt here. So once I took the derivative of h, I should have had my dH dt, my dH dt here, my dH dt here. So I'm sorry about that. So follow me, guys. All right. So once I plug in that to get my 36, well, again, 4 goes into 4 once, and again 4 goes into 36 9 times, right? So we have something that looks like this, or dv dt will be 9 pi feet squared dh dt, right? And so now I could just plug in my dv dt, which was given 8 cubic feet per minute. All right, so 8 cubic feet per minute, and that is going to equal 9 pi feet squared dh dt. Again, these feet will cancel and I will have 1 feet over here, right? I could just divide by 9 pi, divide by 9 pi, and here's the final answer. I'm sorry, guys, but you guys gotta follow me. All right, my final answer will be dH dt, and that's just gonna equal 8 divided by 9 pi feet per minute with my units. All right, so this problem is you got to realize that the fact that they give you that the height is always twice its radius, that's the tricky part here. You got to find that, because we really don't know anything about R. Plug that in into a formula to get the actual formula that we're going to use and differentiate. All right.